In this tutorial, we will see how wfGenes can simplify modeling and generate the necessary code for various workflow management systems using a lightweight graphical user interface running on top of Jupyter notebooks. Later, we will examine wfGenes executor to run our workflow with different engines. Random task graph example demonstrates the capabilities of wfGenes' task coupling and code generation for different workflow management systems. We will see how the GUI provides necessary functionalities to model your workflow and use various executors to perform computation, scaling from personal to supercomputer centers. For the sake of simplicity, as the first example, we consider simple sleep function, which is the common task between these coupled nodes, and resemble computation in real time, real-life applications. As it is explained in the setup section, wfGenes GUI can be run on top of Jupyter Notebook, either on your personal computer or on Jupyter Hub or on a login node of a remote machine using port forwarding or any other setup installation guide that's provided in the setup section. For running wfGenes GUI, please first unload any loaded Jupyter module which is loaded on Jupyter Hub by default from the left side pane of in the software section here. Please unload any loaded module. Then please pay attention to select your proper kernel, which is here is already selected. This is the demo env, and I created with the same instruction that I explained in the setup section. Then here you can just run the cell and import wfGenes GUI from the wfGenes package and run the wfGenes GUI on Jupyter Notebook. As you can see, this is the first view of wfGenes GUI, and we start with setting up our workspace to increase the efficiency in folder navigation in the rest of this demo. Since I previously cloned wfGenes repository, I just navigate to this directory and set it as a workspace, and it contains also the introduction example that random task graph is also located there. Then we proceed with generation phase. We select the random graph folder and the vconfig with 10 nodes, and then we select an input path. Here also for a random graph we do not need any row input or files as an input, but we have to select a path as a dummy path, which is required by tool. Then we choose the firework as the recommended way and tool to run your workflow on supercomputer, thanks to a strong monitoring and management mechanism which is provided by Fireworks repository and Fireworks tool. Then as the final step, we just run the wfGenes and see how the graph looks like. This is the presentation of your task graph, and also as you can see, you can navigate to this folder and see what other output is generated there. We just go through this folder, check the random graph. There are two different folders here, dot folder and Fireworks folder. Dot folder is just for the presentation file, presenting the file in the dot format that cannot be edited here. But here the Fireworks graph, Fireworks file is also generated, which is the equivalent code and model in Fireworks workflow management system for the described task graph in vconfig. We can just go there, have a look by pressing the edit file. We can at least have a look, check everything. We can see here the name is random graph wfGenes, Then we just can change the name if we want. We can say this is hands-on, and the name, and then we can just save this one. Interestingly, then we can close. Interestingly, also we can also edit the wconfig and easily change the underlying code and graph quite interactively. As an example, I just edit the node 4 and add a dummy output that will be consumed as an input in node 7 to modify the graph and also the generated code for Firefox. To do so, I just add an tag name dummy output, and so the length of output changed here. Then I will change also here dummy output. This dummy output generated in node 4 will be consumed in node 7 as an input. Okay, this is only for demonstration purposes. Of course, the wfGenes analysis, the wconfig, and match everything and do some other consideration to generate proper and valid code. And this name should either refer to any other input in the configuration file or a file on a disk. But this is only for demonstration purpose and how you can use wfGenes for modeling. We just run the wfGenes one more time. As you can see, we generate the dummy output and the graph changed, as you can see. And if we just navigate again to the output folder, we see the Firefox also change. And again, since we didn't change the name of wconfig, the files are overwritten, and again the name is changed. We change it again to hands-on. This is the name of the Firefox workflow. We save it, and then we switch here. Also we can switch also here to execution pane. Also we can have a preview of the wconfig to see how our wconfig looks like, how many nodes we have. We can have a look at the list of the functions, inputs, outputs, and keyboard arguments. Then we close it, and we can switch to execution phase. To use Firefox engine, first we need to create an engine with all necessary parameters. Some files like Launchpad and Q adapters are loaded automatically if you use the Firefox engine. And for the execution here, now the kernel is busy because there's rendering the rest of the GUI and just calling other function. As you can see here, just some paths are set and some files are loaded, like Launchpad and Q adapter, which Launchpad is used for configuration file to connect to the database, and the Q adapter is the file and configuration file used to submit jobs on class. For more information about Firefox and underlying files and repository, please refer to the documentation that is also described in the homepage of the wfGenes documentation. Then it is recommended also to open up a terminal in the right of your GUI and just by pressing the terminal button from the new tab, and then we proceed to create a new engine since this is the first version and we just want to demonstrate how it works. We come here and we just specify the proper launch directory, and by pwd command, path to workspace, we just copy paste our home directory and just extend it rgg hands on. And the engine name is not necessary for this experiment since it is used to be matched with the fworker field of the fireworks that in order to different and isolate fireworks from each other and run different fireworks with different resource configuration or on different clusters. But here we just use the BW unit cluster, BWU, which stands for BW unit cluster, and it is the default one, and please do not touch it for this demo. But the other fields is also important in the fireworks configuration file, which we will discuss it later. And you can just go ahead and create your engine. And then the next step is just add your workflow to the database to the later just execute it. We just proceed with the manage workflow pane and then add your workflow, select your configuration file, for the fireworks file and just add it. And as you can see, some important information are printed out on the console, like the fireworks ID. I've just added a workflow, the name of the workflow, and a workflow ID, which is different from the fireworks ID, in fact. Then and also the path to the absolute path to the fireworks file, which is already loaded. Then important point is that when we want to execute the workflow, the name in the query field should match the one that we just want to in fact run, because there can be different workflow with different names and IDs, and we do not want to mess things around, and we want to just run and execute specific fireworks. For this example, we have to just recreate the engine before executing anything with the name of the workflow that is printed out when we just add the workflow. As you can see in the add workflow, the name of the workflow is that one. For creating engine, it's not important the name of the workflow, but when you want to launch and execute, it is important to create proper engine if it's not created before adding the workflow here. And just create the engine, and the engine is created for the local launcher, which is the purpose of this demo. And then we switch to launcher window and start the launcher. Before that, I just want to issue watch SKU command on the command line in order to monitor Slurm activities. This is the job of Jupyter Hub running like 12.5. And okay, we go ahead and start the launcher. But before that, also I want to have a look at the status of the workflow. This is the status of the workflow of the generated workflow where the graph are shown. And this is the status. We go ahead and just start the launcher. As you can see, immediately, almost instantly, the status of job changed. There are probably in the pending state. Yes, this is the status of the jobs in the terminal and the Slurm workload manager. We should wait for the job to be finished and see if they are completed, fizzled, or if they are fizzled, what is the error, and we should face with the failure and relaunch the workflow and see how Fireworks can help us in order to face with the failures, error, and how workflow management systems can help us to face with different scenarios during your simulation. We just refresh the status. As you can see, it is fizzled. 3 workflows are fizzled. We just check and see what is the error. The error is that the module, the necessary module for executing and completing this function, this workflow is not there. In fact, the path is not exported and the executor cannot locate the necessary files. They cannot find the necessary files in order to finish the computation. Then the reason in the framework of the solution in the framework of the Firework is that to load proper queue adapter, and we in the generation phase we can just have a look at the different queue adapters available and how they are different. First, this is the default one, which is already loaded, the myQAdapter.yaml file. We can have a look. As you can see, there is no installation, prerequisite installation in order to export any path or load any module. On the contrast, for example, you can have a look on the RGGQ adapter and see how that one is different. This one is just exporting the necessary Python module, which is the proper, in fact, Q adapter for our simulation. As you can see, the path to the module is just already exported. You can also have a look, for example, on these Q adapter, which are prepared for another workflow. Here, the prerequisite in Q adapter file not only exports some path, but also load some modules on the supercomputer, and also export some environment variables and so on, in order to help the executor to finish the simulation successfully. Then we switch again to execution part. Go ahead and just recreate the engine as is necessary for the random graph example. We just load the new Q adapter, which basically only exports the path to the my function module. We just create a new engine to do that. The tool first stopped engine, the running thread, in fact, the running launcher. We should wait a few seconds because it is a thread and that should be catch and killed. The launcher thread had stopped. Now we can just create the engine one more time, and this time with new Q adapter we need first update the status of this fizzled Fireworks on a database to enable executor to fetch them and run them. The next one is 8. Okay. And then again run the launcher. Same thing again happens. They're in the reserve mode. Here. The jobs are in the pending stage and they will start immediately, and this time hopefully we do not have any error because we load in other proper Q adapter. And later we can also proceed to see how we can just use wfGenes GUI on our personal computer and submit job remotely. Of course, passwordless SSH login should be enabled, but we can use also the remote section of the wfGenes GUI and use our personal computer or laptop and use transfer file buttons easily to transfer files from our personal computer to supercomputer and just handle our workflow remotely thanks to Firefox and database, well-established connection to database, and just in fact do fast prototyping of our workflow and our model. Let's see again, check the status. Okay, this time these nodes are completed, not fizzled, and they do not need any further setup. If we wait, we can see now there are more 4 nodes are running. Node 1763, yeah, 1763. Okay, and if we wait, these jobs will be finished and the whole workflow will finish in a few seconds. But before that, there are some other useful widgets in the wfGenes that we can use, for example, to modify your workflow. If, for example, if you want to change the category field, easily you can just switch the category field here or wworker field here by just specifying the remote query and just specifying the exact ID of your workflow. For example, if you are going to use Firefox from your personal computer and submit jobs remotely, you should update the category field from batch to remote. Or if you are going to use your local resources and run your simulation on your personal computer without using supercomputers, you should update it to interactive one. wfGenes by default just generate the workflow for the batch field, but easily, as I showed, you can just update it through the push button and updating the proper field. Here you can just check. This is the automatically generated workflow for Firefox. As you can see, the category is already batch. And this is automatically generated. And on the database also, if you check or do the query, you can see the category is batch job. But if you want to submit job remotely, you should switch it to remote one, or if you want to go use your personal resources, you should switch to interactive. Do some further query even on our workflows. You can just check the state is completed, the state of that workflow, and also you can check the spec. As you can see, here is the batch job. And please note that I think the states and the category fields can be updated if the Firefox is in the ready state. You cannot change the category of the completed Firefox. Simply, it's not allowed. Okay, let's see. Okay, as you can see, almost all nodes are completed, and this is the last node, which is already running for 20 seconds. I think it will take like 10 more seconds, 20 more seconds, and the job will be finished. And we just show how wfGenes can be an alternative in wfGenes GUI, can be an alternative way to model your workflow, generate necessary code for different workflow management system, which will cover here only Firefox, which is a well-established workflow management system, especially to run, monitor, and manage your workflow on supercomputers. But later we can use also DASParse and also SimStack, which is a commercial tool. but we can use also Dask and Parcel and embedded executor for Dask and Parcel here in order to just specify the amount of resource you want and the time that the job takes, domain to the remote supercomputer, and the launch directory, and just submit your job. And but for the purpose of this demo, I think we covered necessary topics, and the user and will have the introductory and primary insight on the wfGenes. As you can see, the workflow is completed, all nodes are finished, and for doing further query, you can just specify workflow ID to see more detail about the ID, number of launches, and some other stuff that you can also explore and see. Thank you for watching. Please contact us if you have further questions.